All right, so sometimes you just gotta kind of get ready for we got to get ready for a test. So, all right. So what we're looking at here is filling in our 2-column notes. This is going to be a great organization tool for you to use tomorrow. So what we want to do is go through and make sure we've got everything that's organized. So remember with your 2-column notes, the idea is that you fold this piece of paper. So you'll actually be folding right down there to cover it up. This way you can quiz yourself. So if we want to make a box plot, you need 5 pieces of information. One of the things that you need is the median. All right. And remember, when you figure out median, you do need the numbers in order. Sometimes they are placed in order, but you have to look for that. So we need median. We need quartile 1. We need quartile 3. We need the largest number. And we also need the smallest as well. With that information, we can make our box plot. Now, you definitely can go back and look at your lessons of what it actually looks like, but typically, if students say they have this information, they can go ahead and create their box plot.
That was easy.
Now, yeah, I mean, you're right. It's easy to just come up with the numbers. But remember what quartile 1 is. It's also known as the upper quartile. All right. And then quartile 3, also known as the lower quartile. So again, just make sure you're aware of your words as you're going through it. All right, so to find the IQR, in other words, the interquartile range, we need to do 3 things, or we need 3 things. We need quartile 1. We need quartile 3, and then realize that it is a subtraction problem. We will do quartile 3 minus quartile 1. So again, straightforward steps there. Range, it is a subtraction problem, but because it's interquartile, we need to use the quartiles that we have. So what is interquartile range? And again, not how do we find it, but actually what is it? All right, were you thinking it's the middle 50%? Now, again, here, the key thing is the middle. It's where most of the numbers are. So it's where half, all right, it's half the numbers are around the median. So saying the middle 50 gets the job done. When we break it up there, this is where half the numbers are, but not just any half. It's the middle half of the numbers, and the middle 50% that we're looking at. So half the numbers are that are around the median there. So it gives us a good representation of what typically is going on. All right, so MAD, mean absolute deviation. All right, so what do we need for that? Well, the first thing that you have to do is you have to find the mean. All right, that's the first thing that we need. After we find the mean, we use that and we find our deviations. After we find the deviations, we then find our absolute deviations. And then the last thing that we do is we're going to find the mean of the absolute deviations. I'm going to abbreviate there. So again, mean, remember that's where you add them all up and then you divide, all right, by how many numbers that there are. But the key thing that's down here is you're going to find the mean of the absolute deviations, and that's what you did right up here. Highly suggest making a table when you do these styles of problems, and we've got that in your notes. You've got that in your lesson 12 and a lot of your problems. So it's just going to help you kind of organize your information. All right, so what is the MAD, the mean absolute deviation? This is something that we want to make sure that we understand, because we just don't want to say, well, it's the mean absolute deviation. No. What is that? So we got to use some different words. So it is the average. So it is the average, and that's kind of what mean is. All right, so it's the average and its distance. All right, a number is away from the mean. Now this is important because we solved this on our lesson 11, those last two problems that were down there. It's the average. So if we have a very large mean absolute deviation, what that means is that we're going to have numbers that are really spread out because the average distance is going to be far away from the mean. If we have a very small mean absolute deviation, then that means that most of the numbers are hanging around the mean. And again, it lets you know the spread you're dealing with. Are they close together or are we all over the place? So the last one there is what is mean, and we kind of brought this up before. What is mean? Remember, mean is we call it the arithmet. Spelling. All right, let's go back and try that again there. All right, pens. There we go. The arithmetic. Sometimes when I spell and write at the same time, it doesn't work out there. So it's the arithmetic average. All right. You could just say kind of it's the average for it. But the main idea is this is where we add them up and divide. So it's the arithmetic average. So and again, we don't want to know how do I find it. You find it by adding all the numbers up and dividing there. So it's the arithmetic average of all numbers. And yes, to find it, this is where you would go and add up there. So the main thing here is we want you to realize that when we talk about the word mean, we use the word average. Oh, look at that. Mean absolute. It's the average distance. Deviation is the distance from a data point to its mean. So we're just kind of breaking down the words that we've got. That's all that we've got for you. That's all.
Looks good.
It does.